Hey, so I'm back with a different kind of toy that I'm working with right now. I got the FSI 6S flight controller working. So I really need the battery for the quadcopter to be able to calibrate it and get it set up so I can actually test the throttle and calibrate everything on the quadcopter. It's really important when you're doing electronics that you do a proper calibration of your sensors. Like a lot of people don't understand what that is, but it's like you want to create like a base ideal state for how you're doing things, and then typically the main goal of electronics is, like especially in robotics, is like you get that base state of what will be perfect, and then when you actually start testing the device, or you put the robot out there and it's moving around, what you're doing is you're correcting the error that it's going away from your test state. So like in my case, if I wanted to calibrate my quadcopter, I put it flat on the ground, calibrate everything out, and say like that's what should be zero, that's what should be level, everything should be level. And you really want to have a very flat surface when you do that, because on that board there's a bunch of accelerometers and some variation of a gyroscope. And you want it to be flat, because then when the quadcopter goes up, you want to be able to detect that this is tilting in yaw. Let's just say yaw. It's tilting in yaw. And you want to make sure that you can correct that back up to 0 yaw, so it stays hovering. I'm kind of going with it right now with my robot right now. This is Dingus. He's just my little robot. Got an ultrasonic sensor right here, and then 2 photoresistors to detect light. Using a Arduino Uno here. There's a little bit of a circuit here. It's really just to power a head servo, which is located here, and then 2 bottom servos. And this goes to show that you want to be really careful when you're ordering your parts for a robot, because I ordered this chassis and it needed some special like other angle brackets, and because it didn't work, I had to like improvise and put some zip ties down there. So those servos down there are attached with zip ties. It's really bad, but I gotta fix it. I'm using this weird like cell phone battery to power the Arduino, and a 9-volt DC battery to power the servos. And the other thing that I added to it, which I haven't been taking full advantage of, is a Bluetooth module. This is God, I'll put the link to this down there in the description too. This is a Bluetooth module that's super easy to work with in our Arduino. Oh, here it is. DSG Tech. I know it's HC something, but I'll put it in there. It's a really fun Bluetooth module, and when you connect that to the Arduino, all I'm doing is I'm literally reading RX and TX right into here, and then I read it on the serial port. So I could show you, like really simply, how I do that. If you download PuTTY, download PuTTY. Yeah, I'm not gonna do this right now. I'll have to do like a screen capture or something like that. Anyways, you can monitor the serial port. So if you're printing things to the serial port in Arduino, you can read those right on your terminal on your computer and kind of like debug the situation remotely. Now the problem I have right now is, I'll show you. This is a little switch to turn him on. He goes, gets to the wall, definitely knows there's an obstacle there, kind of turns a little bit, but just gets stuck. And so the thing that I have to do is implement a reverse mode in these servos. So I'll put up the entire script that I'm using right now for this guy, and then I'll do a coding video, I guess, to show you guys like how to work with these servos. And it's a lot. It's way more than I thought it was gonna be. I thought that this was gonna be done in like a day, and I did get really far in one day, and then I kind of like put it off for a little bit. So the other trick to getting good at electronics is having patience and just being like, okay, I'm not gonna figure it out today, but I'm going to try again tomorrow and like just be really, really persistent about that. I worked on him, like the preparation for him, getting the parts and all that stuff. That took weeks to get the parts together. And now I have all the parts. You know, it's all wired up. Most people would be like, "Oh, it's done," but there's just minor bugs going on here. Like, he doesn't go in reverse when he detects a wall, so gonna have to put that in there. All right.